Welcome back. And with those overarching principles to experimental design, what we're going to do is focus on a certain class of experimental designs. And again, these are as many as there are stars in the universe, right? But the class that we're going to look at are called randomized comparative designs. And effectively, per the name, it's just all experimental designs that have an element of randomization and comparison between groups. Okay, and and the randomization comes with the chance of assignment of the subjects to treatments. Okay, so and then consequently they also use large samples, and so they satisfy principles 1, 2, and 3 that we were looking for. All right, so the first experimental design that we're going to talk about is completely randomized. Okay, so what we're going to do, I'm going to draw this by a diagram, and this is a common representation. So you will be asked to draw these on sapling and on exams and stuff, but the structure to a completely random design is that you have a sample. Okay, let's say it's very large. So let's say it's 500 individuals. Okay, and that's your sample. And what you do with the sample is that you engage in some sort of random assignment. Okay, and I'm going to abbreviate. And you engage in some random assignment, and then it splits them into some number of groups. I'm going to assume that I have 3. You can assume more, less. I'd recommend no more, or at least 2. So let's say I have kind of group 1, group 2, and group 3. Okay, so I've split them somehow. Okay, and for reference, let's just say, I have, I don't know, 200, 160, and then 140. Okay, so there's, that many in each of these groups. Okay, let's use green to be consistent. Okay. With random assignment, you're not going to get an equal split ever. So if you equally assign these as, like, what, 166, no, not going to happen. Okay. Random processes aren't all that random in some cases. So anyway, you do random assignment. Okay. And then you attach a treatment to each group. Treatment 1, treatment 2, and treatment 3. Okay. And then so they do all these treatments, and then what do you do at the end? Right? You have to measure. So then you measure and measure and measure, and then you're ready to report. Okay, so this is diagram for completely randomized. Okay, block designs. And I guess backing up for just a minute, the idea with completely randomized is that you assign individuals at random to the groups. Okay, there's no other qualifier that we need. Okay, a block design is a little different in that if you have your same group of 500 individuals, you identify that there's some sort of lurking variable. Okay, and so you separate the individuals into different groups based on that. And let me just, for simplicity, I'll just do 2 blocks for right now. I'm going to separate them into 2 blocks, and I'm just going to say block 1 and block 2 first. And this is not random in any way. Okay, so here are your blocks. The blocks can represent any lurking variable. So for instance, in many cases, things have different physiological effects on people of different sexes. Okay, so maybe this is, male and female. Okay, but in general, this would be any level. So you would separate it based on levels of a lurking or confounding variable. Okay, and now within each block, you randomly assign treatments. Okay, so there's kind of a random here, and then it goes into either treatment 1, treatment 2, or treatment 3, and then you measure. Okay, I'm abbreviating this a little bit just for time purposes. Okay, and then similarly with block 2, you engage in a random assignment within block 2 to the 3 treatments. 2, 1, and 3. Okay, and this helps you with the measurements that you take in each block. You can compare across the treatments within the block this way, and so you're kind of controlling for that lurking variable in a different way. Very common to see block designs. Okay, so main idea here is that you take your sample of individuals, purposefully split them based on this lurking variable, whatever it might be, and then engage in random assignment after that. Okay, and also this block levels, don't assume that you need to split it again perfectly equally. It could be that you have 200 people here and 300 people here. Okay, that's perfectly fine. And then again, consequently, the random assignment, you're going to get a split. It's not going to be completely equal between the 3 treatments. Okay, matched pairs. This one is interesting only because it has 2 different interpretations. Okay, the most common is to use a set of individuals that are closely matched. Okay, so effectively think twins. Okay, you get a set of twins, you give one twin treatment A, you give one twin treatment B, they don't know which is which, and then you record the results. That would be kind of type A. Type B is you give the 2 treatments to the same individual twice in a random order. Okay, so let's kind of draw these 2 out. So you get your 500 individuals. Okay, and then you separate them into groups of 2. So here you get the first 2 individuals that are closely related. Okay, and with this group of 2, then you do a random process and assign one to treatment 1 and the other to treatment 2, and then you measure and report. Okay, and same thing here, you get another group of 2 individuals, sort them at random into treatment 1 and treatment 2. Okay, and these 2 individuals have to match very closely based on multiple factors, age, gender, height, weight, etc. Hair color, eye color, I don't know, whatever the researcher's needing to control for. Okay, again, and then this second type, type B, it's of your 500 individuals, you split off, one individual, and you randomly assign, so randomly assign them to treatment 1 and then say treatment 2. So treatment X I'll call, and then you would then have them do treatment Y. Okay, but this can be 1 or 2. We don't know. Okay, so and then you would measure and report. Okay, so these 3 4 technically designs are the designs that we'll be focusing in on in the course. So completely randomized, random at initial assignment, block design, separate based on some level of lurking levels of lurking variables, and then matched pairs where you either have like a twin type approach where you have 2 people closely matched and assigning assigning them to treatments at random, or you're taking one individual and randomly assigning them to treatments.